Alright, hello students, welcome you all once again to this YouTube channel. So today I'm back with it another super cool video where I'm going to discuss with you an excellent trick for hyperconjugation. A very simple trick, or you can say a very simple concept for hyperconjugation. Do watch the complete video because I always say half knowledge is very dangerous. Okay, I'll make this video as short as possible. Alright, first let us start the video. Now in the case of hyperconjugation, alright, in the case of hyperconjugation, we will be discussing hyperconjugation, or we will be observing hyperconjugation in carbocation, alkene and free radicals. Now, how we can observe hyperconjugation? See, whenever a carbon has sp3 hybridized, okay, whenever it will be sp3 hybridized carbon, and to that carbon, if we can see another carbon which has hydrogen, we will name it as alpha hydrogen. And the main concept of hyperconjugation, we will be dealing with this alpha hydrogen. What are alpha hydrogen? See, alpha hydrogen are those hydrogen which are connected to a such carbon that carbon must be connected to another carbon which must be sp3 hybridized. Okay, if you are not understanding, I'll explain you while solving. Okay, you can understand better. Now in carbocation, see, okay, in carbocation this is a sp3 hybridized carbon, because here we have 1 2 3 4 bonds. I have already explained you how to find the hybridization. If you want to watch that video, I'll provide the link in the description box. You can watch it, right? Okay, now this is the sp3 carbon, and to this carbon another carbon is connected. Now here you can see two hydrogen, so two alpha hydrogen we have. Okay, similarly in alkene, this is an sp3 carbon, and to this carbon again we have some more carbons connected, so they are the alpha hydrogen. Next, in free radicals also we have this carbon, that is sp3 carbon, and to this carbon another carbon is connected, and for this carbon the hydrogen which are connected, they are called as alpha hydrogen. Okay, in this manner you can identify the alpha hydrogens. Right, now what are the tricks? Here comes the major and most important tips and tricks. Now, the more the number of alpha hydrogen in a compound, if more number of hydrogen, alpha hydrogen are there, then it means more hyperconjugation effect we can observe in that compound, and it has more stability. The more the alpha hydrogen, the more the stability. Very simple concept, no need to get tensed. More alpha hydrogen, more hyperconjugation. If more hyperconjugation, more stability. That's all. Okay, now let us apply the tips and tricks what I told you on some examples. Alright, now here the first question. Now you can see here they are asking which is most stable. Right, we have to identify which is most stable. What I told you, the more the alpha hydrogen, the more the stability. Right, now we can see here we have, as you can see, 3 plus 3 plus 3 9. So 9 alpha hydrogen we have, and you can see this is tertiary. Am I right? This is tertiary carbon, and as you can see for this carbon, two CH3 groups are connected, so this is secondary. And how many alpha hydrogen are connected? 3 plus 3 6. So 6 alpha hydrogens are connected in second option. Now if you look at the third option, it is primary carbon. Why? Because only one CH3 is connected. Now how many alpha hydrogens? 3 alpha hydrogens are connected here. Now in this we have 0 alpha hydrogen. Now what is the stability order? What I told you, the more the alpha hydrogen, the more the stability. Therefore first option has the most highest number of alpha hydrogen. Therefore first option will be the greatest. It means first option will be having the most stability. Second, then third, then at last fourth. We can also write this as tertiary greater than secondary greater than primary. This is the stability order in case of hyperconjugation. That's all. Very simple, right? Let's move on to the next problem. See here, again they are asking which is most stable. See, in this manner only they'll be asking us the questions, whether in NEET, KSET or any other regional examination. In almost all the examination they'll give you the option like this, and we have to guess which is most stable, which is least stable, and we have to arrange, or somewhat they'll be giving us in this type of questions. Alright, so let us see the question. Here again we can see, if we focus on this carbon is connected to two other carbon, therefore this is secondary carbon. And here if we consider this carbon, this is connected to only single carbon. Am I right? So this will be primary carbon. And if you see this carbon is connected to 1 2 3. This carbon also we have to include in our calculation. Therefore this is connected to 3 carbon. Therefore this is tertiary carbon. Now what I told you, the order: tertiary greater than secondary greater than primary. Am I right? Similarly the option is 3 greater than 2 greater than 1. That's all, very simple. Just see the alpha hydrogen, okay, just see the alpha hydrogen. Or if you are confused with alpha hydrogen, see the degree, whether it is tertiary, secondary or primary. You know this order: tertiary greater than, secondary greater than, primary. That's all. Any question asked from hyperconjugation, you can solve within few seconds. That's all. Now again, one important exception, not exception, an important point, okay, I would like to tell you from hyperconjugation. Now imagine you are given deuterium, you know, right? It's an isotope of hydrogen, okay. Deuterium is an isotope of hydrogen. Now if you are asked to calculate, I mean to guess the stability, which is more stable among the deuterium and hydrogen with respect to inductive effect, then deuterium will be more stable. Which case? In case of inductive effect. Similarly, if CD3 and CH3, okay, CH3, you know, right? CH3. Similarly, CD3. Among this, if they ask you to calculate the stability order with respect to inductive effect, then also your answer will be CD3 will be more stable. Okay, now comes the major point. As we are dealing with hyperconjugation, now suppose if they are given, okay, if they gave you CD3 and CH3, and now if they ask you to calculate which is most stable in case of hyperconjugation, with respect to hyperconjugation, then CH3 will be most stable, right? Because in hyperconjugation we will not be dealing with inductive effect, we will be dealing with alpha hydrogen. Okay, now I'll apply this concept on one example. Okay, now here we have one example. See here, for this carbon we have 3CH3, then for this carbon 2CH3 and 1CD3, and for this carbon only one CH3 and 2CD3 have connected. Then for last compound, for last carbon, all the other elements or all the other carbon atoms are connected with D, means deuterium. But let me tell you one thing, in this type of cases we don't have to consider deuterium, we only have to see the alpha hydrogen. Remember my point, we only have to consider alpha hydrogen. Now in this compound, how many alpha hydrogen we have? 3 plus 3 plus 3, 9 alpha hydrogens, right? Now in this compound 6 alpha hydrogen, in this 3 alpha hydrogen, in this 0. How many? 0 alpha hydrogen. Therefore, what is the stability order? What I told you, the more the alpha hydrogen, the more stable. Therefore, answer, what is your answer? 1 greater than 2 greater than 3 greater than 4. We don't have to see deuterium or whatever it may be, we just have to see the alpha hydrogen. We have alpha hydrogen more in this compound, so this will be most stable. 1 2 3 4, that is your order. That's all, simple, right? So hope you like the video. If you like the video, don't forget to hit the like button. So do like, share and subscribe, because if you like my video, it motivates me to make more such video for you guys. Okay, stay tuned, I'm uploading still more videos for you guys. So thank you, thanks a lot.